Another important thermal property is the specific heat, which is denoted by C sub T. It is basically a measure of how efficient a material can store thermal energy. It is mathematically defined as the amount of heat needed to raise the temperature of a substance by 1 degree. Now you may ask, why is it necessary for us to determine the heat storage capability of a material? To answer this, let me introduce you to the thermal wheel. It is also called the rotary heat exchanger. The way this works is that hot air coming from the outside is to be cooled by the cold air coming from the inside of an air-conditioned space. Both the hot outside air and the cold exhaust air pass through different ducts, but the thermal wheel crosses these two ducts. The way it works is that it continuously rotates at a set speed. Then the portion of the wheel which is exposed to the hot air becomes heated. Once this portion of the thermal wheel rotates to the duct where the cold exhaust air passes through, heat will transfer from the thermal wheel matrix to the cold air, thereby heating up the exhaust air. Now you may ask, why is it necessary for us to know about the specific heat in this example? Knowing the specific heat will allow us to select the best material to use in manufacturing the thermal wheel matrix. Aluminum is one of the most widely used materials for thermal wheel matrices due to its high specific heat. The last thermal property that we are going to discuss is thermal diffusivity. It is denoted by the Greek letter alpha. It is defined as the ratio of how fast heat is conducted in a material to how much heat is stored in the material. Heat capacity is a thermal property which is similar in significance to specific heat. It is also a measure of the heat storage capability of a material. It is the product of the material density and its specific heat. Now, what insight can we derive from thermal diffusivity? Based on the magnitude of alpha, we can say that the higher the thermal diffusivity, the better is a material in conducting heat. But the lower the thermal diffusivity, the better is a material in storing heat.